Right now, I will start to talk about the MATLAB code. And as you can see, x0 and y0, I let them be the endpoint of the cycloid. And we use equation 1 to solve the end radian of this cycloid. And also, we use the endpoint of y0 to solve the radius of this cycloid. And we can use the math expression of the cycloid to see x is r times t minus sine t, and y, I let it upside down, equal to minus r times e minus cosine t. In the previous math part, we can see that the Togacron curve can be seen as a cycloid, so I use the math expression. And the gravity is 9.8, delta time is 0.01, and 3 initial condition. And this is this one, and this one. Okay, and let us see the time. Okay, so while x1 is smaller than x0, x2 smaller than x0, x3 smaller than x0, v equal to y1 times square root of gravity divided by r times square root of 2 times g times y1 minus y10 plus 0.01 divided by square root 2 times g times y1, and this one is the endpoint solution to the original solution for the velocity, and this one is the endpoint solution to the initial point condition, and this is their ratio, and I use their ratio to compute the velocity of x, and use the velocity of x, we can calculate it x1, and use x1, we can solve the radian and use the radian to express y1, the next y1. And if x1 is larger than x0, x1 equal to x0 and y1 equal to y0, and we do the loop, same as the second ball and the third ball. So after this, we plot x, y, c. This is the cycloid. And hold on, we let the label of x equal to x, the label of y equal to y, and we plot the first ball as the red ball, the second ball as the blue ball, and the third ball as the black ball, and they are all upside down because I upside down first in the equation. And then let the P1, P2, P3 have a label named red, blue, and black. And I have a string to see the time going, and I to calculate the time, and we use the frame to see the animation of this ball. Okay, and we use this for j equal to 1 to I minus 1 and image. We change frame to image and change image to the RGB. And if j equal to 1, we write it as a GIF. And the loop count is infinite, means that we can always see the cycloid, and else this time we write it to the GIF2, but every time we update it again, and we can see the ball is continue to move. And right now we will see the GIF of this MATLAB code. And this is the GIF for the MATLAB code, and we can see that the 3 different initial values of the red ball, the blue ball, and the black ball falls to the lowest part almost at the same time, but there's still some errors. But this is very close to the result what we expected.